everyone. Today I am going to take a lecture of Discrete Mathematics, chapter number 1, and today's topic is the pigeonhole or pigeonhole principle. Okay, so what do you mean by the pigeonhole? So pigeonhole, that means pigeonhole principle says that if there are many pigeons and a few pigeonholes, then there must be some pigeonholes occupied by two or more pigeons. So what is the meaning of the definition of the pigeonhole principle? That means we have a many pigeons, okay, and a few pigeonholes. That means the pigeon greater than the pigeonhole, number of pigeon greater than the pigeonhole. So then there must be some pigeonholes occupied by two or more pigeons because of the pigeonhole is less. Okay. So here, for example, let A and B be two sets and mod of A greater than mod of B. That means we use a positive value. Okay. So mod of B greater than mod of B for any function from A to B. So there exists, if we consider the two elements A1, B2 belongs to A, then FA1 is equal to FA2. Okay, so here, for example, if 11 shoes are selected from 10 pairs of shoes. So, what is the meaning? What do you mean by this sentence? The 11 shoes are selected from 10 pair of shoes. Okay, so there must be a pair of shoes among the selection. That means what? Here we have the 11 shoes are selected from 10 pair of shoes. That means what? Here we use the 11 shoes. So one shoe is mismatched. Okay. So here, for example, n pigeonholes and n pigeon. Then one of the pigeonhole must be occupied by at least. This is the extended of the pigeonhole principle. So in case n pigeonholes and pigeon, then one of the pigeonhole must be occupied by at least n minus 1 upon n plus 1 pigeons. Okay, so according to this example, here we use 11 shoes and the 10 pair of shoes. So this is the other name is the shoe box principle. Okay, shoe box principle is other than of the pigeonhole principle. Got it? So here m pigeonhole and n pigeons. So this is the extended of the pigeonhole principle. So formula is n minus 1 upon m plus 1 pigeon. Okay. So this is the example. If we have the 7 colors, okay, if we have the 7 colors are used to paint 50 bicycles. We have the 7 colors and we used to paint the 50 bicycles. Okay, so at least 8 bicycle will be of same color. Okay, so we solve this question and we find out. So at least 8 bicycles will be of the same color. Okay, so what is the solution? So this question is depends on the pigeonhole principle. That means the extended pigeonhole principle. So in this question here n is equal to 50 because of we have the 50 bicycle. Okay, and m is equal to 7. That means here m is 50 and m is equal to 7. So here the formula is what? What is the formula of the pigeonhole? Pigeonhole formula is n minus 1 upon n plus 1. Okay, so you put here all these values n and m. So n is equal to 50 minus 1 upon 7 plus 1. Okay, so 50 minus 1 is equal to what? 49 divided by 7 plus 1. So this is the 8. 7 7 are 49 plus 1 is equal to 8. That means at least 8 bicycle will be of the same color. So this is the simple topic of according to your pigeonhole principle. Okay. Our next topic is the permutation and the combination. That means combination, that means NCR, and permutation, that means NPR. So you have already seen in the different types of the question based on the NCR combination and NPR, that means the permutation. So our next topic is the permutation and the combination. So we take a one example. So with the help of example, we can easily find out the what is the permutation and the what is the combination. Okay. So for example, we selected three students from four brilliant students. Okay. Listen carefully. We selected three students from the four brilliant students. So what is the group of the three students? The group is, first one is A, B, C. Okay, A, B, D, B, C, D, and C, D, A. Okay, so we have four types of the group A, B, C. We use the three brilliant student, or A, B, D, or B, C, D, or C, D, A. So we have the four combination of the brilliant students. Okay, so this is the example of the we use three students according to four brilliant students. Okay, so we have the four group is according to the students. But in case if we given a rank first, second and third. Okay, if we given a rank in each group, okay, according to first, second, third. So how many combinations are here? So first one is, for example, we tag first group. Okay, first group means A, B, C. Okay, so if we given this is the first rank or second or third, or if we given this first rank or second or third rank, so how many group are here? So here we write first one is A, B, C. That means first rank, second rank, and third rank. Next one is what? A, C, B. First rank, second rank, third rank. Next one is what? B, A, C. Okay. First rank, second rank, third rank. Next one is what? B, C, A. First rank, second rank, third rank. B, C, A. Next rank is what? C, A, B. First rank, second rank, and third rank. And next is what? C, B, A. C, B, A. Okay. So here we have the total 6 group. First rank, second rank, third rank, ABC, or ACB, first rank, second rank, third rank, or BAC, first rank, second rank, or third rank, or BCA, first rank, second rank, or third rank, or CAB, first rank, second rank, or third rank, or CBA, first rank, second rank, and third rank. Okay, so this is the we have the four brilliant students, and if we select the group of the three brilliant students, so we have four ways. Okay, but in case if we given the rank according to group, and every group they consider the first, second, and third rank, because of in every group we have three students. So we have total 6 ways. Okay, so the total is what? Total is 4 into 6 is equal to 24. That means if we have the 4 brilliant students and we find out the group of the students, and every group we have the 3 students, and after that in every group we give a first, second, and third rank. So total base is 24. Okay, so what is the permutation and what is the combination according to this example? So here in first case, Okay, in first case that means what? We arrange here according to group. So in first case, the order of the selection is not considered. Order of the selection is not considered. While in the second case, it is important. Why it is important? Because of in every group, we write here the rank, first, second and third. Okay, so first case what? The order of the selection is not considered, but in the second case it is important. Okay, and next point is what? In first case we select a group. Okay, but in second case we arrange the elements in order. So second point is again very important. In the second case, we select a group, but in we arrange the elements in order. That means in the first case, according to our first, the order of the selection is not considered, but in second case, it is important. Okay, but the second point is what? Second point is we select a group. Okay, but in second case, we arrange our elements. So what do you mean? According to your example, we have the four students. Okay, and we met here the three pair of three groups: ABC, ABD, VCT, and CDA. So we have the four groups. Okay, so according to this, we are not considered in the order. Okay, but in the second case, we arrange the elements according to every group. That means first group have the six ways. Second group again have the six ways. Third group again have the six ways. And the fourth group again have the six ways. So every group have the six ways, and we have the four groups. So 4 into 6 is equal to 24. Okay. So what is the definition of the permutation and the combination? So the selection of object without consideration of order of their selection is called combination. That means what? The selection of object without consideration of the order. That means if we not consider the order, so this is the combination. Okay, but what is the permutation? So selection of object with consideration of the order of their selection is called the permutation. That means according to combination without consideration of the order, and according to permutation with consideration of the order. That means this is your combination and this is your permutation. That means combination, so without consideration of the order, and permutation with the consideration of the order. Okay, so this is a simple definition according to your permutation and the combination, and we have different types of the examples depends on the permutation and the combination. So how we classify this question is depends on the permutation, or this question is depends on the combination. So if we use the order of selection, so this is your permutation, and if we not consider the order of the selection, so this is your combination. Okay, so let's start our example depends on the permutation and the combination. This is the example of the depends on the permutation and the combination. The question is out of 9 cabins in office. In an office, out of 9 cabins, in how many ways 4 cabins can be assigned to 4 officers? Okay, that means we have the 4 officers and we have the 9 cabins, and we choose the 4 cabins. Okay, so what is the solution? Solution is that if one first officer, okay, we have the 4 officers, so first officer, so how many ways for choose of office? Because of we have the 9 cabins, so in the first officer select the ways is 9. That means first officer choose any one office out of the 9 cabins. Okay, so this is the 9. So remaining is what? Remaining is 8. So second officer, the how many cabins are remaining? Total 8. Okay. Third officer, how many cabins are remaining? So 9 and 8 are considered here. So third one is the 7 cabin. And the fourth one is what? Fourth one is 6 cabin. Okay, so this is the answer of according to your question. Because of according to our question, we are given in the 9 cabins and we choose the 4 cabins. So we have the 4 officers. So according to first officer choose any of the one cabin according to out of the 9 cabins. Okay, so we write here 9. So one cabin is occupied according to first officer. Okay. So second officer, the remaining cabin is what? Remaining cabin is 8. Okay. So second cabin is also occupied. So according to 9, two cabins are occupied. So remaining is what? Remaining is the second cabin. So third officer, how many ways they chosen the cabin? So 7 ways. Okay, 7 cabins. But third cabin is also occupied. So according to 9, 3 cabins are occupied. That means remaining cabin is what? Remaining cabin is 6. So according to fourth officer, we have the 6 cabins. So this is the combination, or this is, you can say that this is the combination of the 9 into 8 into 7 into 6. That means the total number is what? Total number is 3024. 9 adds 72 into 7 into 6. Okay, so here the total base is 3024. So this is the answer of the out of 9 cabin in office. So how many ways 4 cabins can be assigned to 4 officers? So answer is total base is 3024. Okay, so this is the example of the depends on the permutation and the combination. Okay, so I will continue this topic in our next lecture.